Entropy. All too often you'll read claims by atheists and Darwinian evolution advocates that the idea of life coming from non-life or a believed macroevolution would not violate the second law of thermodynamics. If you take nothing else away with you from this next chapter, it should be this. When any overall direction of change due to natural processes has been detected, evolution has only been observed going downhill, never uphill. There have been no exceptions to this rule. It's an observed law of nature. That is where the empirical science ends, and above and beyond that, the speculation of anything opposite to such often begins somewhere within Darwinism or atheism. And that's it. You could stop right there and not read on, and you've at least already got the basic point. However, because of the flood of arguments and bad information out there, from those who advocate their almost superstitious belief in upward change, and upward mutations, we need to look some more and examine it closely in more detail. Let's separate the proven facts from the vague imaginations. This observable downhill process is sometimes referred to as the thermodynamic gradient. Many choose to remain ideologically committed to naturalistic explanations due to the narrow definition imposed on the word science, and therefore it is constrained to natural phenomena only, through test and observation, to distinguish the known from the unknown, as a way of increasing knowledge. Or it could be that someone is emotionally intent on remaining a committed atheist regardless of what can or cannot be observed, because of emotional anti-religious reasons, especially perhaps a bias against older, more traditional belief systems, and so they will stay within the philosophy of materialist naturalism. What caused the universe to exist cannot be observed, but we do observe a natural law that points to a more ordered beginning, not a simple one. So, rational scientists point out the elephant in the room here, and it should not be ignored, when trying to explain how the tested observable physical evidence, even when mathematically described as a scientific law, and kept within the arbitrarily constrained naturalistic definition of empirical science, overwhelmingly demonstrates to those observing it, that every physical thing we know of so far must have begun in a more ordered condition. The question of how everything began more ordered, is an uncomfortable one for atheists, who protect their ideology of willfully denying God's possible existence behind the illusory philosophical shield of exclusive naturalism, so that the question about God's existence might be excluded from all speculation. But scientifically there is no getting around the empirical experimental problems with any of these strategies. The claim that quantum fluctuations evolved into humans is anathema for empirical science. And this, by the way, is not a straw man argument, as hard as it might be for many of us to believe. Some scientists have inferred this idea in one way or another. But those who are purported to be intellectual giants who advocate such fanciful upward processes from quantum fluctuations are simply wrong by scientific standards, because such imagined upward transformations are not supported by experiment and observation, and disagree with the second law of thermodynamics. This is the anti-scientific superstition of atheism. Anti-scientific because it goes against all experiments, superstitious because the opposite has never been observed to happen in the entire history of scientific inquiry, and atheism because materialist atheism is only valid if such an idea of upward change were true. But any notion of upward change over time is manifestly false, repeatedly scientifically disproven, consistently demonstrated to be the opposite of reality. In everyday life we see things becoming more messy and disorganized over time, and when left to nature itself, we never see such processes reverse. The law of decay is only one way. Isaac Newton was someone earlier who acknowledged the idea of everything running down when he wrote, "For while comets move in very eccentric orbs in all manner of positions, blind fate could never make all the planets move one and the same way in orbs concentric, some inconsiderable irregularities excepted which may have arisen from the mutual actions of comets and planets on one another, and which will be apt to increase, till this system wants a reformation." Newton, 1706 Optics, 2nd edition, quoted in H. G. Alexander 1956. The Leibniz-Clark Correspondence, University of Manchester Press. So it seems Newton argued that the universe requires intervention from the Creator, otherwise it would become more disorganized over time and eventually decay due to various motions and interactions. In modern times it has been realized that under extreme conditions, gravitational waves can significantly sap the orbital energy from orbiting bodies, so in principle, this is another way that orbits of planets eventually decay, although it takes a very long time. One of Newton's contemporaries, Leibniz, strongly objected to Newton's idea and wrote, "Sir Isaac Newton and his followers have also a very odd opinion concerning the work of God. According to their doctrine, God Almighty wants to wind up his watch from time to time, otherwise, it would cease to move. He had not, it seems, sufficient foresight to make it a perpetual motion." Leibniz, First Letter, in Alexander 1956. But Newton's ideas have ultimately held up over time, and in more recent history, probably since the invention of steam engines, such principles were later extended to include not just the motion and interactions of large bodies, like stars and planets, but also the most fundamental known submicroscopic particles of nature. Ironically, not just creationists but even an atheist like Richard Dawkins himself would probably say that it would be irrational to let anyone tell you how to think without good reason, since that would be intellectually lazy to put faith in such. Informed rational thinkers will acknowledge that science has proven it impossible to make a perpetual motion machine. And this is because of the very principle being discussed here. We must therefore approach these subjects with the neutral skepticism, open-mindedness, and logical critical thinking that they deserve, and make up our mind about them based on evidence, not only a belief, and certainly not from being clouded by anti-religious sentiment. One could imagine that perhaps such a person would take this skeptical position to prevent people from becoming overly dogmatic on certain issues. No matter what any of us think, we all need to challenge our beliefs. We all need to ponder that most complex device we have, that is our brain. And use it? In this case, how? Some say that belief in God is just a product of the human imagination because no human has ever seen God, which indeed in some sense is quite true. If there is an omnibenevolent, omnipotent creator with unlimited power and superintelligence, then why are there asteroid collisions, hurricanes, tornadoes, floods, various kinds of disease, an aging process, death, suffering, evil, and so forth? Intelligent design advocates might say that science alone cannot give us a complete answer. Others will postulate Darwinian explanations such as survival of the fittest or blind indifferent random natural processes, not from intelligent causation. But this fails to explain the amount of existing order that is still observable. But we certainly cannot ignore the amount of disorder at present. We cannot, in principle, ignore the chaos, evil, and suffering in the world. Nonetheless, it seems that conditions in the past were more ordered than they are now. To reconcile this intriguing paradox and find consistency in all of this, creationists often cite the biblical explanation for the order and the disorder. Essentially, the Bible gives us a narrative of how it all got here, how it all got messed up, and how it will get fixed. Those who are committed to constraining themselves within the philosophy of exclusive naturalism might find certain parts of this supernatural explanation philosophically objectionable. In this view, the biblical explanation provides us with a model to test, a just-so story, a description of how a rebellious supernatural being, identified as Satan, persuaded the first created man and woman to disobey God's one simple command and rebel against the Creator. So, an argument arose which contended that humankind could exist better without God's direction, and therefore God has allowed humankind to exercise their free will in this way, and to try out this kind of independence for a period of time, and then see what happens as a result, but with dire warnings about the consequences for those who choose to do so, and for now, unfortunately, also often for those who are trying not to. and since sin entered the world, God has removed himself from it until an appointed time, and since then all creation has been running down and degenerating, and larger portions of our world are becoming more physically corrupted and more evil, as time goes on. That's what is typically the argument from the book of Genesis, which the later biblical writers refer to, although the post-flood book of Job infers that in the supernatural realm the issue is also playing out and mankind has become part of Satan's ongoing miserable experiment until an appointed time, until the issue of universal sovereignty is settled, and so it is argued that this is the reason for much of the chaos we observe today. Philosophically, from a religious point of view, and for the long-term greater good, it would seem to be the statistically inevitable price for creating beings with free will, and might only seem justifiable if every wrong ever committed could eventually be mitigated by the all-powerful God, Jehovah. Hence the Christian doctrine. Many scientists, atheists, and naturalists object to these arguments based on the measurement problem and what they might claim to be the unfalsifiable aspect of it. So, how testable is it? We may well wonder, is there any scientific evidence that at least agrees with this biblical explanation? How does it compare to secular hypothetical models? Christians often cite the Bible as being a practical handbook to coping with life's challenges, and avoiding a lot of unnecessary problems, because it is seen by many as being divinely inspired by God, while others disagree. What do we make of all this? Some people in the modern technological era are skeptical of this idea that has been born from ancient writings, and choose not to believe in the existence of God. It follows, if a person chooses to dismiss all the archaeological verifications of the various biblical accounts as mere confirmation bias, and doesn't want to believe in God's existence, then they are left to ponder how all the order and complexity we see around us came into being. There are good empirical reasons why a scientist would require an alternative explanation of how complex integrated order can come from nothing, or at the very least, how it could ever emerge from randomness, uniformity, or chaos. The brain, for example, is considered by science to be the most complexly ordered object in the universe. And yet science has discovered that complexity has its universal nemesis, entropy. So, not just differentiation but also functional complexity is the opposite of entropy. Within any system you can imagine, for every functional complex arrangement of particles, there is an almost infinite amount of possible non-functional disorganized more entropic arrangements within that same space of possibilities, that is to say, allowed by that same system. Science observes finely balanced physical laws that enable our universe to exist, and all life within it to exist. Science also observes mind-boggling integrated complexity in the systems that make all life possible, such as DNA code, and a vast plethora of molecular machines inside cells, mostly interdependent on one another for their continued existence, and so that the pre-programmed self-replication of the total system, that they are all part of, is possible. What process puts such seemingly impossibly improbable functional arrangements together, instead of everything being a random evenly spread world of molecules? That idea, of course, does not even begin to address the question of why molecules existed in the first place, nor their intricate subatomic components, and the pre-existing laws that governed their construction to begin with. Someone, with a purely naturalistic worldview, would simply assume it to be that way from natural processes and laws of nature, despite the vast improbabilities that can be calculated from various systems and their possibility spaces. For those who believe the multiverse hypothesis plausible, that raises a more difficult problem of how many other less organized hypothetical universes there could have existed by chance as opposed to any possible organized functional universe, if it even happened that way at all. Nobody knows how to test it sufficiently, nor a logical progenitor of this imagined multiverse scenario. One of the main reasons for this idea is that atheists help to find an escape from the theological implications of the universe having a beginning, and it being fine-tuned. But, even if ultimately you could logically imagine, or mathematically somehow come up with, a satisfactory idea, of some past eternal naturalistic process, there is still a very fundamental argument that it might never overcome, in terms of avoiding the necessity of an intelligent creator, and that is the mathematically proven law of increasing entropy. Both empirically and mathematically this has been demonstrated in so many different ways, and in so many diverse systems, that the entropy law is ubiquitous. The theological implications of a more organized beginning seem unavoidable. Despite the many beautiful and orderly things that we see in nature, we also observe the relentless progression toward chaos and disorganization. Why does everything decay over time? Why does heat always flow in the direction of cold? Why do areas of high pressure expand and flow toward areas of low pressure? Why overall do things become colder over time and run out of energy? Why do things deteriorate in various ways? Why does specified information become more scrambled over time? What causes all these phenomena to always run down? In short, the law of increasing entropy is the overall definition for every type of decay. This is a common objection that is raised against the Darwinian evolution theory by creationists, ID advocates, many scientists, and others. Entropy is an observed phenomenon that can be tested and fundamentally described. It can be mathematically theorized, and in more recent times computer simulated, and the predictions made by these models have without fail been verified with empirical accuracy, and are repeatable. Some atheistic Darwinian evolutionists frequently hand-wave this argument off and claim that such arguments made by creationists are based on a misunderstanding of the second law of thermodynamics and the fundamental law of increasing entropy. Others, not so much. So it is important to take this argument seriously. Therefore we need to drill right down into the subject, not relying on just mathematical equations that invoke a convenient scale of reckoning, but more importantly examine the fundamental statistical logic that explains the first principles of this natural law. This convenient scale of reckoning is what is often referred to as being in the second law of thermodynamics. Evolution is a rather slippery word. According to the well-known creationist Henry M. Morris, Ph.D., the law of increasing entropy is an impenetrable barrier which no evolutionary mechanism yet suggested has ever been able to overcome. Abiogenesis or macro-evolution, vaguely imagined upward changes, and entropy, often produced from observable and computable downward changes, are opposing and mutually exclusive concepts. If the entropy principle is really a universal law, then, upward Darwinian, evolution must be impossible. The entropy principle is the law of increasing entropy, and is the fundamental explanation for the second law of thermodynamics, just so we're all on the same page here. It is explained by the mathematical concept of statistical mechanics to describe change over time, the evolution of all systems in nature, showing all systems head toward a condition of higher probability, more randomness over time, the fundamental explanation of why everything, so far known, decays. Some might view such statements as oversimplified, but it goes far deeper than that. Some people might mistakenly think that the underlying cause of entropy, or decay, is purely physical, when in fact, the underlying cause of it is predominantly mathematical, statistical, or informational. It is to do with the laws of probability. Probability is what largely governs the change over time, or the evolution, in the arrangement of parts at the subatomic, micro, and macro scales of any system in the universe, but in this case, it is a downhill evolution, not observably uphill. It is going downhill in the sense that it is heading toward more randomness, more disorganization, toward a condition of higher probability. Not just material objects but also specified information decays over time, in the sense that it becomes more scrambled and increasingly meaningless. There are many ways of defining the law of increasing entropy. Today it is known as the principal explanation for the second law of thermodynamics. It underpins why things decay, and how they tend to become more disorganized, random, spread out, equalized, more mixed and homogeneous as time goes on. It is commonly defined as being a measurement of disorder and randomness within any given system, although in some situations this definition is not adequate. It can also be viewed as the progressive loss of usable energy in a system. Another way of explaining it is looking at arrangements of things and seeing how they tend to head toward arrangements of greater disorganization and randomness when left to nature, that is to say, not intervened upon, where no outside energy or information is added to a system, so in this sense, it is a closed system, and thus more disorder and more decay are inevitable. Even these explanations sometimes do not completely describe entropy either, since some things that are mixed can separate and stratify, because of gravity and their different densities and particle sizes and weights. Snowflakes and crystals can form out of random arrangements of molecules below a temperature threshold. Perhaps the most comprehensive way of explaining it is that all things are heading toward a state of higher probability, or maximum uniformity, or a maximum state of rest, or towards maximum equilibrium, or they are becoming more the same as one another, or heading toward the lowest state of potential energy, depending on at which level of detail on which particular system it is being studied. The common thread in all these situations is, they do not reverse back to their previous condition when left to themselves. In some of those situations where specified complexity is not a factor, an inflow of more energy from an outside source will, in some sense, randomly reverse the situation, not atom for atom, but, according to the first law of thermodynamics, where energy conservation is taking place, according to the first law. But even then some usable energy is being lost in the transfer according to the second law. An example of this would be energy from the sun being fed onto one part of the earth at any given moment in time. Even living organisms that utilize the sun's energy still are subject to efficiency losses. But they start with highly ordered energy harnessing mechanisms already in place to begin with, and those highly functional configurations did not just magically pop into existence by themselves. Creationists argue that this runs contrary to the ideological part of the Darwinian evolution theory, which claims hypothetically, that things not only evolve in the observed downward direction of increasing disorganization, but can also evolve somehow in an upward direction and become more orderly, more organized, more differentiated, and more complex over time, due to natural selection, acting on imagined upward mutations and other unlikely happy accidents, and so this idea, for atheists, is a kind of placeholder for the ultimate creator of things instead of God. Evolutionists want to believe that not only physical things can somehow get more organized, but they want to also believe that functional information can somehow increase as well by some natural means of selection. Creationists accuse this idea of upward natural processes as being somewhat religious, which is manifestly ironic. Others even more harshly say that it is completely credulous. How specified does DNA need to be for life to be possible? In recent times, scientific investigation has begun to show that DNA contains a very organized functional code, and very specified, with a sophistication far beyond any computer code that humans have ever written. It requires much unsubstantiated belief to think that statistical mechanics would not also work against the genetic codes of each offspring from mutations and natural selection. Why would genetic code not also be, over successive generations, subject to the same law of increasing randomness and disorganization as anything else in nature? No one has observed anything different in this regard. Even the same generation of creatures age and die, let alone the long-term viability of their offspring's reproducible genome over many successive generations through time. How can the concept of Darwinian evolution be possible if everything in the universe is becoming more random and chaotic, and heading toward a state of greater disorganization over time? How can non-life spontaneously become life? Is life really that simple? Were life forms ever that simple in the past? Is that even possible to have some gradual process, from non-life, up to life? Can we even believe it to be possible, especially if we add to this problem of what creationists and many scientists claim is true, that the simplest forms of self-replicating life are irreducibly complex? But even if we could somehow convince ourselves that it were not true, how can things, in a certain localized area, ever go thermodynamically uphill, instead of always heading in the observable downhill thermodynamic gradient through time? Using reductionism, when any system has been observed in isolation, theoretically a closed system, why has there not ever been observed any exceptions to this natural law? The only logical retort is to suggest that it is logically possible, but to look for such a ludicrous improbability in so many highly complex systems is astronomically more difficult than finding a needle in a haystack. This retort then is almost certainly unfalsifiable, making the idea of upward evolution seem untestable and impossible, and therefore unscientific. One can certainly calculate the mathematical improbability within various systems of nature which, in systems relevant to this investigation, inevitably result in possibility spaces with numbers that are vastly many times the amount of fundamental subatomic particles in the observable universe. A common mistake some evolutionists make is by confusing the second law with the conservation of energy in their analogies to try and show why upward change might be possible in an open system that receives raw energy input from the outside. Some things within a decaying system will go uphill, using the conservation of energy law, which is the first law of thermodynamics, not because entropy is reversing. And so we are still quite justifiable in saying that entropy never reverses. A ball rolling down a hill has the momentum to roll up another hill some way. A ball hitting the ground will bounce back up. Part of a water wheel moves upward as the wheel is turning. The temperature increases on the side of the Earth facing the Sun, etc., are all examples of conservation of energy, but such energy is still flowing toward less usability. Randomness continually increases overall and energy is becoming less and less usable, and it never goes the other way. This is the law of diminishing returns, and it is happening throughout the entire universe. It is these tiny niches within this framework that the philosophy of materialist evolutionism tries to stay tenable, but it is a shrinking zone of willful ignorance. If a student is sitting for a science exam, they would never want to rely on this type of stupidity to help them pass it. So, it's important to recognize the first law of thermodynamics. It describes how the total amount of energy in the universe is always the same. It can change its forms, but the total amount remains the same, whether it be available for use or not. The total amount of energy is always conserved in the universe. It can neither be created nor destroyed. It simply breaks down into different forms of energy of an equivalent amount. In essence, decays into other forms, or might include smaller amounts of the same form as part of the total breakdown, but the total amount of energy always exists as one form or another and remains the same amount, some of it usable, some of it not usable, and the unusable portion continually increases over time. Morris says, the first law is itself a strong witness against evolution, since it implies a basic condition of stability in the universe. The fundamental structure of the cosmos is one of conservation, not innovation. However, this fact in itself is not impressive to the evolutionist, as he merely assumes that the process of evolution takes place within the framework of energy conservation, never stopping to wonder where all the energy came from in the first place nor how it came to pass that the total energy was constant from then on. It is the second law, however, that wipes out the theory of evolution. There is a universal process of change, and it is a directional change, but it is not an upward change. This argument has never been successfully refuted with properly conducted experiments. Nevertheless, committed evolutionists, and atheists, in an attempt to protect their worldview from collapsing in deepest humiliation, have to argue that this is a misunderstanding of the second law. Their belief system requires them to accept the idea that localized micro-reversals of entropy can happen if greater entropy is happening elsewhere to compensate. However, no localized reverse violations of this law have ever been observed. This doesn't necessarily mean that it never happens, depending on how you define it, but it has never been seen or definitively measured in any real way. You can make a mathematical argument to show the probability of a localized micro-reversal of entropy, but in complicated systems, the amount of possibility space required for such a calculation goes way beyond the amount of known fundamental particles in the observable universe. And so, it therefore becomes immediately obvious that the universe is neither old enough nor big enough to make the idea plausible. It is also tenuously speculated that an out-of-equilibrium fluctuation has a remote chance of producing more specified complexity, that nature can select for survival and preservation, but that would require somehow achieving subsequent replication, for further improvement, which seems like implausible superstition. Since there is no empirical evidence for this hypothetical preservative localized anti-entropy, it remains outside of science, and so far, the said ability of such fluctuations has only proven to be an article of faith for Darwinian evolutionists. It seems that such ideas are still incapable of explaining the origin of functional integrated complex biology, even the simplest irreducible function of self-replicating life, found in the cell, which is not simple at all but has complex functionality beyond imagination. A scientifically illiterate Darwinist might argue that a seed that germinates and develops and grows into a complicated plant structure is an example of increasing complexity, but in reality it is not, but instead is a downhill process stemming from the specified information already programmed, which earlier on in the process was contained inside the seed. So fundamentally, we are asking how it is possible to have an increase in specified information. All physically integrated complexities are contingent on this more fundamental question of specified information. The only empirical observations of increasing specified complexities that have ever been demonstrated by humans in the real world are humans causing it. Cars, planes, computers, etc. are all ultimately products of intelligent guidance and not just natural process alone. Nobody has observed biological specified complexity increase, but there have been observed numerous times decreases, commonly known as mutations. Which group of people are more superstitious? Biblical creationists, or materialist evolutionists? According to scientists and creationists and consistently repeatable experimental evidence, everything is heading downhill, hence the entropy law obtained from rigorous measurements. But despite this, against all known observations, Darwinian evolutionists like to speculate and hope that some things, yet to be discovered, might be able to go uphill, and somehow have an increase in their complexity, caused by unknown mindless natural processes and natural selection. It is truly breathtaking the amount of dogmatic speech on various websites that religiously and credulously advocate Darwinian beliefs in this regard, despite all empirical evidence, experimental and experiential, to the contrary, and without exception. The overwhelming evidence-based falsification does not stop the evolutionist propaganda from perpetuating this anti-scientific dogma. This particular superstition prevails simply due to the pack mentality, peer pressure, fear of ridicule, loss of grant money, and loss of career. For those that go against such evolutionist propaganda, that pervades certain secular institutions that favor atheism or materialist philosophies by excluding the God question. Consensus doesn't change proven facts. The reason that entropy is now regarded in mainstream science as a physical law, and the fundamental explanation for the second law of thermodynamics, is because it has up until now withstood all empirical tests designed to try and falsify it, and therefore considered immutable, unchallengeable, absolute, unassailable, incontrovertible and indisputable, and that is now largely why there is now in physics the axiom, the second law of thermodynamics. This particular phenomenon appears to be undeniable and inexcusable, and therefore also the extrapolation that things started more organized. And the question of why we exist, and how we exist, might not be meaningless after all. How dare anyone take that away? To summarize, according to the first law of thermodynamics, energy is never destroyed but just changes form and is therefore conserved in the universe. The second law of thermodynamics, explained by the entropy law, says that usable energy is lost from a system because it either escapes out of an environment into a less orderly arrangement somewhere else, becoming more spread out and more uniformly distributed, or in a closed system heads toward a greater state of equilibrium, randomness, or being more evenly mixed, and more uniformly distributed. It is said that the entire universe is constantly heading toward maximum disorder, that is to say, maximum uniformity, maximum evenness, maximum smoothness, or a maximum possible state of rest, the lowest state of potential energy in a system, the theoretical heat death of the universe. It is said to be a downhill process. Actually, closed systems are only a theoretical idea for the experimental purpose of reductionism. We can, by isolating parts of the world and postulating rather idealized conditions in our problems, arrest the increase, but we cannot turn it into a decrease, said the famous astronomer, Sir Arthur Stanley Eddington. In reality, as far as anyone knows, there is no such thing as a closed system in the absolute sense, because, even these so-called closed systems, will over time, eventually decay. Some say that protons might be the exception to this rule. Atoms eventually decay, depending on their various types, that is the type of element. Some have a higher probability than others of decaying in only seconds or minutes, days, years, decades, centuries, millennia, or possibly over millions, many billions, and trillions of years according to the laws of probability due to the uncertainty and random behavior of the subatomic particles from which they are made. For example, the simplest element, hydrogen, apparently takes vast amounts of time to decay if ever, perhaps quadrillions of years when not subjected to the extreme conditions of a star, although there is currently no experimental evidence that proton decay occurs at all. However, some postulate that it might occur by the extreme forces around black holes. But the element radium decays very quickly by comparison, which is not limited to extreme conditions. Radium emits alpha particles, 2 protons and 2 neutrons bonded together, believed to be made possible by the theory known as quantum tunneling. It emits also beta particles, high-energy electrons or positrons. It also emits gamma rays, the most energetic wavelength of light. Newton was unwittingly starting to get a glimpse of what has been postulated by many physicists, that in the distant future the entire universe is progressively becoming more and more disorganized and will end in heat death, where all the atoms might disintegrate and all the energy will eventually dissipate, and if protons are not truly closed systems and do decay, then this might be true. It still seems an open question, although atoms can be smashed apart in particle accelerators. Indeed, there are subatomic particles in the universe traveling significant fractions of the speed of light and are bound to occasionally smash into each other. So, many seem to agree with Newton and also take the argument even further in that it appears that without divine intervention, heaven and earth might indeed pass away, but even after matter and energy have dissipated, it seems that the laws would remain, if the whole thing were left to run its natural course. The word entropy was invented in 1865 by German physicist Rudolf Clausius, who lived 1822 to 1888. From Greek entropia, meaning a turning toward, from en, meaning in, and trope, meaning a turning, a transformation. Clausius invented the word entropy in 1865 for what he called the transformational content of the body. The word is said to state predictively that the entropy of the universe tends toward a maximum. Martin J. Klein, the scientific style of Josiah Willard Gibbs, in A Century of Mathematics in America, 1989, this idea is still generally accepted and has become part of the structure of thermodynamics, according to the definitions of mainstream science. Morris says, the word entropy means literally in turning. It is derived from the two Greek words en, meaning in, and trope, meaning turning. The concept is of something spiraling inward upon itself, exactly the opposite concept to evolution. Macro-evolution is speculated or imagined but never witnessed, change outward and upward. Entropy is observed and verified, change inward and downward. Ludwig Boltzmann, who lived February 20, 1844, September 5, 1906, developed a deep statistical understanding of why entropy is increasing, possibly everywhere in the universe. The Boltzmann equation is well known in physics. His belief in the existence of atoms was disputed at the time, due to either skepticism, dogmatic willful ignorance, and ridicule from some of his more prominent contemporaries who had very big egos, which was very discouraging. Tragically, it was only after Boltzmann committed suicide that atoms were proven to exist, and his theory of statistical mechanics was more firmly justified, and the entropy principle was more thoroughly understood. In order to understand the concept, an intuitive illustrative way of explaining it is best for most people. It is not a difficult concept to understand. If you want to be a physicist or an engineer and have accurate measurements of it, then it is to your advantage to learn the mathematical equations. For the rest of us, it can be easily understood using illustrations and examples in everyday life. We can simply start by looking at things we see around us in everyday life. They all decay over time. Things become messy over time. Metal rusts. Things corrode. The heat from a fire radiates outward and the fire eventually goes out. A hot object transmits its heat to a cooler object. The air inside a room tends to become evenly dispersed at the same pressure and temperature in all parts of the room. Orderly arranged things become more disorganized and random, and more spread out or more evenly mixed as time goes by. Light, heat, radiation, and all other forms of electromagnetic energy tend to spread out into space. All these things are in some sense irreversible and are different manifestations of entropy increasing. So, what do we make of all this? For one thing, there is an asymmetry to the process. It has never been seen reversing. It seems to overwhelmingly have a one-way direction through time. Why is this so? Why have none of these processes in closed systems ever been observed reversing? When something decays, the situation doesn't reverse. When we drop something and it smashes, obviously it is highly unlikely that all those resulting fragments will ever reassemble themselves back to the way they were before they were smashed apart. Why? Because, mathematically speaking, there is only one way for it to reassemble to the way it was before, but virtually an infinite number of other ways for things to happen differently, instead of happening exactly in the reverse from which it smashed apart. So these systems contain vast possibilities but usually only one organized possibility, and in this case all other possibilities disorganized, what seems to be an infinite amount of random possibility space. We can ask the same question about the possibility space of all possible biological genetic mutations, and how many of those possibilities will turn out beneficial for survival, within the genome of the organism's offspring. We can also ask if any of those rare beneficial genetic mistakes would ever represent upward change, an overall improvement, if they could ever produce an increase in the amount of functional information of the genetic code, instead of just diminishing returns. And even if on some incredibly rare occasion there was this vaguely imagined, super unlikely, upward mutation, involving information gain, how many degenerative deleterious mutations would be passed on to the offspring along with it, and also along with each successive generation of offspring? It seems from this that the only logical conclusion we can draw is that the organism must continually devolve, continually accumulate more and more entropy within its genome, with each successive generation of offspring. This also might provide a scientific way of determining the age of a species' existence, based on its rate of decay, that is to say, its rate of devolution. This basic principle of virtually infinite improbability can be applied to entropy in general and is said to define the direction of time's arrow. In reality, the number is not always quite infinite but probably finite, but large beyond imagination, almost beyond description. For the number of different possibilities within some complex systems, although some believe that the possibilities in many of those systems may be infinite due to the Heisenberg uncertainty principle at the micro level of reality, where it is impossible to know both the exact position and momentum of a fundamental particle, and so, according to one interpretation, it is largely indeterminate. Either way, the probabilities that are invoked are a measurement of our ignorance. Determining the level of entropy in a system is therefore stating our level of ignorance of the system, because no human can track the position of every molecular particle in a system at any given time, and so we can only sum it up in a more convenient scale of reckoning, known as the second law of thermodynamics, an overall measurement of the amount of randomness in an otherwise ordered system, which therefore is our amount of ignorance of that system, a specific type of ignorance. It is interesting that in science, arguments from ignorance are usually frowned upon, but in this case it is a scientific law. We thus might have to either re-evaluate arguments from ignorance or scientific laws, and by extension both secular and non-secular belief systems. This deeper explanation of phenomena first started to be realized back in the early days of steam engines. People like the Scottish scientist James Clerk Maxwell and others wondered why the compressed steam inside the cylinder of the engine wanted to equalize with the air outside, which was therefore pushing the piston. When the existence of atoms was proven, it was asked, what were the individual atoms doing to produce this effect? This led to some profound implications about the workings of nature, and not only of the universe's possible future, but also sheds light on some aspects of its past condition, and perhaps its origin. Even before the Big Bang theory had been accepted in mainstream cosmology and before the steady-state theory of the universe had been discarded, even when theoretical physicists postulated the universe as being past eternal, without a beginning to its existence, some physicists were starting to realize the profound implications in the law of increasing entropy. At Cornell University, Richard Feynman described the character of physical law and how it gives us the distinction of past and future in one of his famous lectures. In Chapter 5, The Character of Physical Law, The Distinction of Past and Future. This lecture was delivered by Richard Feynman, in November 1964, at Cornell University. Richard Feynman explores the paradox, that while microscopic physical laws are time-reversible, the macroscopic world that we humans experience shows a clear, irreversible directionality. He highlights that this arrow of time stems from increasing disorder, entropy, and yet, paradoxically, the fundamental laws themselves do not distinguish between forward and backward, past and future. Intriguingly, science cannot explain how the initial, highly organized conditions of the universe got there, which have been decaying ever since. Here it is, the following: the distinction of past and future. It is obvious to everybody that the phenomena of the world are evidently irreversible. I mean, things happen that don't happen the other way. If you drop a cup and it breaks, you can sit there a long time waiting for the pieces to come together and come back into your hand. If you watch the waves of the sea breaking, you can stand there and wait for the great moment when the foam collects together, rises up out of the sea, and falls back further out from the shore. It would be very pretty. As a matter of fact, the demonstration in such lectures is usually made by having a section of moving picture in which you take a number of phenomena, and run the film backwards, and then see all the laughter. The laughter just means that this isn't gonna happen in the real world. But actually that's a kind of weak way to put something which is so obvious and deep as the difference between the past and the future, because even without an experiment, our very experiences, inside, are completely different for past and future. We remember the past, we don't remember the future. We have a different kind of awareness about what might happen than we have of what most likely has happened. The past and the future look completely different psychologically, and the questions of memory, of apparent freedom of will, in the sense that we feel that we can do something to affect the future, but none of us, or very few of us, believe that there is anything we can do to affect the past. And remorse and regret and hope and so forth are all words which distinguish perfectly obviously the past and the future. Now, if the world of nature is made of atoms, and we too are made of atoms and obey physical laws, this obvious distinction between what happened, the past and the future, and this obvious irreversibility of all phenomena, you would think would most likely have obviously its interpretation in that some laws, some of the motion laws of the atoms are going one way, that the atom laws are not such that they can go either way, that there is somewhere in the works, some kind of a principle that Uxels only make Wuxels, and never vice versa, and so the world is turning from Huxley character to Wuxley character all the time, and that this one-way business of the interactions of things is the thing that makes the whole phenomena of the world seem to go one way. And yet, we haven't found it. That is, in all the laws of physics that we have found so far, there doesn't seem to be any distinction of the past and the future, that the moving picture should work the same way going both ways, and the physicist who looks at it should not laugh. Details, now to be explained. Let us take the law of gravitation as our standard example. If I have a sun and a planet that I started off in some direction, going around the sun, and then I take a moving picture, and run the movie backwards and look at it, what happens? The planet goes around the sun, the opposite way of course, it keeps on going around in an ellipse. The speed of the planet is such that the area swept out by the radius is always the same in equal time. It just does exactly the way it ought to do, perfectly satisfactory, it cannot be distinguished from the one going the other way. So the law of gravitation is of such a kind, that it doesn't make any difference if you show any phenomenon involving only gravitation running backwards on a film, it will look perfectly satisfactory. You can put it more precisely this way. If in a given instant, all the particles in a more complicated system were to have every one of their speeds reversed suddenly, then the thing would just unwind through all the things that it wound up into. If you have a lot of particles doing something, and then you suddenly reverse the speeds, they will completely undo what they did before. This is in the law of gravitation, which says that the velocity changes as a result of the forces and so on. If I reverse the time, the forces are not changed, and so the changes in velocity are not altered at corresponding distances. And so each velocity then has a succession of alterations made in exactly the reverse way that they were made when that went out before, and it is easy to prove that the law of gravitation is time reversible. The law of electricity and magnetism, time reversible. The laws of nuclear interaction, time reversible as far as we can tell. The laws of beta decay, that we talked about at a previous time, also time reversible. The difficulty of the experiments of a few months ago which indicate that there is something the matter with it, something unknown all about the laws, suggests the possibility that in fact beta decay may not also be time reversible, but we shall see. But at least the following is true: this beta decay that we're talking about, which may not be time reversible, is a very unimportant phenomenon for most ordinary circumstances. The possibility of my talking to you does not depend on that happening, although it does depend on chemical interactions. It depends on electrical forces. It doesn't depend much on nuclear forces at the moment, but it depends also on gravitation. But I am one-sided. I speak, and a voice goes out into the air, and it doesn't come sucking back into my mouth when I open it, and this irreversibility cannot be hung on the phenomenon of beta decay. In other words, we believe that there are, in the world, most of the ordinary phenomena, which are produced by atomic motions, which are according to laws which can be completely reversed. So we will have to look some more to find the explanation. If we look at the planets moving around the sun more carefully, we soon find that it isn't quite right. For example, the Earth's rotation on its axis is slightly slowing down. That's due to tidal friction, and you can see that friction is something which is obviously irreversible. If I take a heavy weight on the floor, and push it, it will slide and stop. If I stand and wait for it, it does not suddenly start up and speed up and come back into my hand. So a frictional effect seems to be irreversible. But a frictional effect, as has been discussed at another time, is the result of the enormous complexity of the interactions of the block with the wood, the jiggling of the atoms inside, that the organized motion of the block is changed into disorganized, irregular wiggle-waggles of the atoms in the wood, so that therefore we should look at the thing more closely. As a matter of fact, we have here the clue to the apparent irreversibility. I take a simple example of, if we have blue water, say ink, and white water, that's without ink, in a tank, with a little separation, and then pull out the separation very delicately, then the water starts to separate, blue on one side and white on the other side. And wait a while. Gradually the blue mixes up with the white, and after a while the water is Luke blue, I mean it is sort of 50-50, the color uniformly distributed throughout. Now if we wait and watch this for a long time, it does not by itself separate. You could do something. You can get the blue separated again. You could evaporate the water and condense it somewhere else and collect the blue dye and dissolve it in half the water and put the thing back how it was before. But while you were doing all that, however, you yourself are causing irreversible phenomena somewhere else, so, by itself, it does not go the other way. And that gives us some clue. Let us look at the molecules. Suppose that we took a moving picture of the blue and white water mixing. It would look funny if we run it backwards, because we shall start with uniform water and gradually the thing will separate. It will be obviously nutty. Now if we were able to magnify the picture, so that every physicist can watch, atom by atom, to find out what happens irreversibly, where the laws of balance of forward and backward broke down, so you start and you look at the picture, you have blue atoms, it's ridiculous, but let's call them that. You have atoms of one kind and atoms of another kind, jiggling all the time, in thermal motion, wiggling and bouncing. If we were to start at the beginning, we should have mostly atoms of one kind on one side, and atoms of the other kind on the other side. Now these atoms are jiggling around, billions and billions of these atoms, and if we start them with one kind all on one side, and the other kind on the other side, we see of course that in their perpetual irregular motions they'll get mixed up, and that's why the water gets to be more or less uniformly blue. But let us watch any one collision selected from that picture, and in the moving picture the two atoms come together that way and bounce off this way. Now you run that section of the film backwards, and you find the pair of molecules moving this way bouncing off that way. And the physicist looks with his keen eye, and measures everything, and says, that's all right. That's according to the laws of physics. If two molecules came this way they would bounce that way, and if they came in that way they would bounce off this way. It is reversible. The laws of molecular collision are reversible. So, if you watch too carefully, you cannot understand it at all, because every one of those collisions is absolutely reversible, And yet, the whole moving picture shows something absurd, which is that in the reversed picture the molecules start in the mixed condition, blue white and so on, all mixed up, and as time goes on, through all the collisions, the blues separate from the white. But they just can't do that. But that's not natural, that the accidents of life should be such that the blues will separate themselves from the white. Yet if you watch this reversed movie very carefully, every individual collision is okay. Well, you see that all there is to it is that the irreversibility is caused by the general accidents of life, that if you start with a thing that is separated like this and just make irregular changes, it does get more uniform. But if you start with something that's uniform, and make irregular changes, it doesn't get separated. It could get separated. It's not against the laws of physics that the molecules bounce around so that they separate, it is just unlikely. It would never happen in a million years. And that's the answer. Things are irreversible only in a sense that going one way is likely to go, but going the other way, although it is possible and is according to the laws of physics, wouldn't happen in a million years. It's just ridiculous to expect that if you sit there long enough, the jiggling of the atoms will separate a uniform mixture of ink and water into ink on one side and water on the other. Now, if I had put a box around my experiment, so that there were only 4 or 5 molecules of each kind in the box, as time went on they would get mixed up. But if you're patient, I think you could believe in the perpetual irregular collisions of these molecules. After some time, not necessarily a million years, maybe only a year, that if you kept watching, accidentally they get back more or less like this, enough on either side of the box, in the sense at least they get back far enough to say, that if I draw a straight line through the middle, all the whites would be on one side of the line and all the blues on the other. It's not impossible. However, the actual objects with which we work have not only 4 or 5 blues and whites, but they have 4 or 5 million atoms. And it's just not likely that 4 or 5 million are all going to get separated like this. And so the apparent irreversibility of nature does not come from the irreversibility of the fundamental physical laws, it comes from the characteristic that if you start with an ordered system, and have the irregularities of nature bouncing, then the thing goes one way. Therefore the next question is, how did they get ordered in the first place? That is to say, why is it possible to start with the ordered? You see, the difficulty is that we start with an ordered thing, we don't end with an ordered thing. One of the rules of the world is that the thing goes from an ordered condition to a disordered. Incidentally, this word order and disorder is another of these terms of physics which are not exactly the same as it is in ordinary life. The order need not be interesting to you, human beings. It's just a question that there's a definite situation, all on one side and all on the other, or they are all mixed up, and that's the order to disorder. Maybe you like it mixed up, but that's not more order anyhow. The question is, then, how does the thing in the first place get ordered? And why, when we look at any ordinary situation, which is only partly ordered, we can conclude that it probably came from more ordered. If I look at a tank of water, in which the water is very dark blue on one side and very clear white on the other, and a sort of bluish water in between, and I know that the thing has been left alone for 20 or 30 minutes, then I will guess that it got this way because it was bluer before, the separation was more complete in the past. If I wait longer, then the blue and white will get more intermixed, and if I know that this thing has been left alone for a sufficiently long time, I can conclude something about the past condition. The fact that it is smooth in the can only arise because it was much better in the past, more satisfactorily separated in the past, because if it were not more satisfactorily separated in the past, in the time since then, it would have become more mixed up than it is. So, it is therefore possible to tell, from the present, something about the past. In fact, physicists do not usually do this much. Physicists like to think that all you have to do is say, these are the conditions, now what happens next? But our sister sciences have a completely different problem. In fact, all the other things that are studied, history, geology, astronomical history, all have a problem of this kind. They are able to make predictions of a completely different type from those of a physicist. A physicist says, in this condition I'll tell you what will happen next. But a geologist will say something like this, I have dug in the ground and I have found certain kinds of bones. I predict that if you dig in the ground you will find a similar kind of bones. The historian, although he talks about the past, can do it by talking about the future. When he says that the French Revolution was in 1789, he means that if you look in another book about the French Revolution you will find the same date. What he does is to make a kind of prediction about something that he has never looked at before, documents that have still to be found. He predicts that the documents in which there is something written about Napoleon will coincide with what is written in the other documents. The question is how that is possible. The only way that is possible is to suggest that the past of the world was more organized, in this sense, than the present. Some people, physicists, have proposed at one time that the way the world became ordered is this, that the whole universe was just irregular motions, like the mixed water, that if you waited long enough, with very few atoms, a few of the molecules could have got separated accidentally, that all that has happened is that the world has been going on and going on and going on, and it fluctuated. That is the term used when things get a little out of ordinary, it fluctuated, and now we are watching the fluctuation undo itself again. How do we know that isn't the case? You say, well, how long you would have to wait. I know, but if it did not fluctuate far enough to be able to produce evolution, to be able to produce an intelligent person, we would not have noticed it, so we had to keep waiting until we were alive to notice it. We had to have had at least that big a fluctuation. But this is incorrect, I believe. I think that's a ridiculous theory for the following reason. If the world were much bigger, and there were atoms that were all over the place, and they started from a completely mixed up condition, all over, and I happen only to look at the atoms in one place, and I found the atoms that separated, I would have no way to conclude that the atoms anywhere else would be separated. In fact, if the thing were a fluctuation, and I noticed something odd, the most likely way that it got there, is that there's nothing odd anywhere else. That is, I have to borrow odds, so to speak, to get the thing lopsided, and there is no use of borrowing too much. It's much more likely, of all the possible ways in which these few atoms on one side and these other few on the other side, of all the possibilities the most likely condition of the rest of the world is mixed up. Like what we saw with the blue and white water. And therefore, although when we look at the stars and we look at the world we see everything is ordered, it could be a fluctuation. The prediction would be that if we looked at a place where we haven't looked at before, it would be a disordered mess, that the separation of the matter into stars which are hot and space which is cold, which we have seen, although if you say it could be a fluctuation, then in places where we haven't looked, we would expect to find that the stars are not separated from the space. And since every time we make a prediction that in a place where we have not looked we'll see the same statement about Napoleon, or we'll see stars in a similar condition, or that we'll see bones like the bones that we've seen before, the success of all those sciences indicates that the world did not come from a fluctuation, but came from a condition which was more separated, more organized, in the past than at the present time. Therefore I think it's necessary to add to the physical laws, the hypothesis, that in the past, the universe was more ordered, in the technical sense, less mixed up, than it is today, and that this statement, is the added statement that is needed to make sense, and to make an understanding of the irreversibility. That statement itself is of course lopsided in time, it says that something about the past is different from the future. But it comes outside of the province of what we ordinarily call physical laws, because we try today to distinguish. Maybe someday we will do that, but we do today distinguish between the laws which tell how something moves if you start it in a certain way, and those statements about how the universe got the way it gets, or has been, what it was in the past and what it's going to get to be. the statement of the physical laws which govern the rules by which the universe develops, and the law which states the condition that the world was, in the past. That's considered to be astronomical history. Perhaps someday that will also be a part of physical law. Now there are a number of interesting features of irreversibility that I would like to illustrate. One of them is to see how, exactly, an irreversible machine really works. Suppose that we build something that we know ought to work only one way, and what I am going to build is a wheel with a ratchet on it, a saw-toothed wheel, with sharp-up notches, and relatively slow-down notches, all the way round. The wheel is on a shaft, and then there is a little pawl, which is on a pivot and which is held down by a spring. Now the wheel can only turn one way. If you try to turn it the other way, the straight-edged parts of the teeth get jammed against the pawl and it does not go, whereas if you turn it the other way it just goes right over the teeth, snap snap snap. You know the sort of thing, they use them in clocks. And a watch has this kind of thing inside so that you can only wind it one way, and after you have wound it, it holds the spring. It is completely irreversible in the sense that the wheel can only turn one way. Now it has been imagined that this irreversible machine, this wheel that can only turn one way, could be used for a very useful and interesting thing. As you know, there is a perpetual irregular motion of molecules, and if you build a very delicate instrument it will always jiggle because it is being bombarded irregularly by the air molecules in the neighborhood. Well, that is very clever, so we will connect the wheel with a shaft that has 4 vanes, like this. They are in a box of gas, and they are bombarded all the time by the molecules irregularly, so the vanes are pushed sometimes one way, sometimes the other way. But when the vanes are pushed one way the thing gets jammed by the ratchet, and when the vanes are pushed the other way, it goes around, and so we find the wheel perpetually going around, and we have a kind of perpetual motion. That is because the ratchet wheel is irreversible. But actually we have to look into things in more detail. The way this works is that when the wheel goes one way it lifts the pawl up and then the pawl snaps down against the tooth. Then it will bounce off, and if it is perfectly elastic it will go bounce bounce bounce, all the time, and the wheel can just go down and around the other way when the pawl accidentally bounces up. So this will not work unless it is true that when the pawl comes down it sticks, or stops, or bounces and cuts out. If it bounces and cuts out there must be what we call damping, or friction, and in the falling down and bouncing and stopping, which is the only way this will work one way, heat is generated by the friction, so the wheel will get hotter and hotter. However, when it begins to get quite warm something else happens. Just as there is Brownian motion, or irregular motions, in the gas around the vanes, so whatever this wheel and pawl are made of, the parts that they are made of, are getting hotter, and are beginning to move in a more irregular fashion. The time comes when the wheel is so hot that the pawl is simply jiggling because of the molecular motions of the things inside it, and so it bounces up and down on the wheel because of molecular motion, the same thing as was making the vane turn around. In bouncing up and down on the wheel it is up as much as it is down, and the tooth can go either way. We no longer have a one-way device. As a matter of fact, the thing can be driven backwards. If the wheel is hot and the vane part is cold, the wheel that you thought would go only one way will go the other way, because every time the pawl comes down it comes down on an inclined plane on the toothed wheel, and so pushes the wheel backwards. Then it bounces up again, comes down on another inclined plane, and so on. So if the wheel is hotter than the vanes it will go the wrong way. What has this got to do with the temperature of the gas around the vanes? Suppose we did not have that part at all. Then if the wheel is pushed forward by the pawl falling on an inclined plane, the next thing that will happen is that the straight vertical side of the tooth will bounce against the pawl and the wheel will bounce back. In order to prevent the wheel from bouncing back we put a damper on it and put vanes in the air, so it will be slowed down and not bounce freely. Then it will go only one way, but the wrong way, And so it turns out that no matter how you design it, a wheel like this will go one way if one side is hotter and the other way if the other side is hotter. But after there is a heat exchange between the two, and everything is calmed down, so that the vane and the wheel have come to be at the same temperature, it will neither go the one way nor the other on the average. That is the technical way in which the phenomena of nature will go one way as long as they are out of equilibrium, as long as one side is quieter than the other, or one side is bluer than the other. The conservation of energy would let us think that we have as much energy as we want. Nature never loses or gains energy. Yet the energy of the sea, for example, the thermal motion of all the atoms in the sea, is practically unavailable to us. In order to get that energy organized, herded, to make it available for use, we have to have a difference in temperature, or else we shall find that although the energy is there, we cannot make use of it. There is a great difference between energy and availability of energy. The energy of the sea is a large amount, but it is not available to us. The conservation of energy means that the total energy in the world is kept the same. But in the irregular jiggling of the atoms, that energy can be spread about so uniformly that, in certain circumstances, there is no way to make more go one way than the other, there is no way to control it anymore. I think that I can give you some idea of the difficulty, in this way. I do not know if you have ever had the experience of sitting on the beach with several towels, and suddenly a tremendous downpour comes. You pick up the towels as quickly as you can, and run into the bathhouse. Then you start to dry yourself, and you find that this towel is a little wet, but it is drier than you are. You keep drying with this one until you find it is too wet, and you try another one, and pretty soon you discover a horrible thing, that all the towels are damp and so are you. There is no way to get any drier, even though you have many towels, because there is no difference in some sense between the wetness of the towels and the wetness of yourself. I could invent a kind of quantity which I could call ease of removing water. The towel has the same ease of removing water from it as you have, so when the towel touches you, as much water comes off the towel onto you as what comes off you to the towel. It does not mean there is the same amount of water in the towel as there is on you. A big towel will have more water in it than a little towel, but they have the same dampness. When things get to the same dampness, then there is nothing you can do any longer. Now the water is like the energy, because the total amount of water is not changing. If the bathhouse door is open and you can run into the sun and get dried out, or find another towel, then you're saved. But suppose everything is closed, and you can't get away from these towels or get any new towels. In the same way, if you imagine a part of the world that is closed, and wait long enough, in the accidents of the world the energy, like the water, will be distributed over all of the parts evenly until there is nothing left of one-wayness, nothing left of the real interest of the world as we experience it. Thus, the temperatures gradually becomes equal on both sides, like the ratchet and Paul and Vane's situation, and the wheel does not go round either one way or the other. Or with our blue and white water experiment, one side doesn't get bluer again. In the same way, the situation is that if you leave any system long enough, it gets the energy thoroughly mixed up in it, and no more energy is really available to do anything. Incidentally, the thing that corresponds to the dampness, or the ease of removing water, is called the temperature, and although I say when two things are at the same temperature, it does not mean they have the same energy in them. It means that it is just as easy to pick energy off one as it is to pick it off the other. You sit them next to each other, nothing apparently happens, they pass energy back and forth equally, but the net result is nothing. So when things have become all of the same temperature, there is no more energy available to do anything. The principle of irreversibility is that if things are at different temperatures and are left to themselves, as time goes on they become more and more at the same temperature, and the availability of energy is perpetually decreasing. This is another name for what is called the entropy law, which says the entropy is always increasing. But never mind the word, stated the other way, the availability of energy is always decreasing. And that is a characteristic of the world, in the sense that it is doomed to the chaos of molecular irregular motions. Things of a different temperature, if left to themselves, tend to become the same temperature. If you have two things at the same temperature, like water on an ordinary stove without a fire under it, the water is not going to freeze and the stove get hot. But if you have a hot stove with ice, it goes the other way. So, the one-wayness is always to the loss of the availability of energy. That is all I want to say on the subject, but I want to make a few remarks about some characteristics. Here we have an example in which an obvious effect, the irreversibility, is not an obvious consequence of the laws, but is in fact rather far from the basic laws. It takes a lot of analysis to understand the reason for it. The effect is of first importance in the economy of the world, in the real behavior of the world, in all obvious things. My memory, my characteristics, the difference between past and future, are completely involved in this, and yet the understanding of it is not prima facie available, by knowing about the laws. It takes a lot of analysis. It is often the case that the laws of physics do not have an obvious direct relevance to the experience, but that they are abstract from the experience to varying degrees. In this particular case, the fact that the laws are reversible although the phenomena not, is an example. There are often great distances between the detailed laws and the main aspects of real phenomena. For example, if you watch a glacier from a distance, and see the big rocks falling into the sea, and the way the ice moves, and so forth, it is not really essential to remember that it is made out of little hexagonal ice crystals. Yet if understood well enough, the motion of the glacier is in fact a consequence of the character of the hexagonal ice crystals. But it takes quite a while to understand all the behavior of the glacier. In fact, nobody knows enough about ice yet, no matter how much they've studied the crystal. However, the hope is that if we do understand the ice crystal, we shall ultimately understand the glacier. In fact, although we have been talking in these lectures about the fundaments of the physical laws, I must say immediately that one does not, by knowing all the fundamental laws as we know them today, immediately obtain an understanding of anything much. It takes a while, and even then it is only partial. Nature, as a matter of fact, seems to be so designed, that the most important things in the real world appear to be a kind of complicated accidental result of a lot of laws. To give an example, nuclei, which involve several nuclear particles, protons and neutrons, are very complicated. They have what we call energy levels, they can sit in states or conditions of different energy values, and various nuclei have various energy levels. And it's a complicated mathematical problem, which we can only partly solve, to find the position of the energy levels. You can understand that it's complicated, and therefore there is no particular mystery about the fact that nitrogen with 15 particles inside happens to have a level at 2.4 million volts and another level at 7.1 and so on. And the exact position of the levels is obviously a consequence of an enormous complexity. But the remarkable thing about nature is that the whole universe, in its character, depends upon precisely the position of one particular level, in one particular nucleus. In the carbon-12 nucleus there is a level at 7.82 million volts, it so happens, and that makes all the difference in the world. The situation is the following. If we start with hydrogen, and it appears that in the beginning or the earliest times, the world was practically all hydrogen, then as the hydrogen condenses, comes together under gravity, and gets hotter, nuclear reactions can take place, and it can form helium, and then the helium can combine only partially with the hydrogen and produce a few more elements, a little heavier. But these heavier elements disintegrate right away back into helium. Therefore for a while there was a great mystery about where all the other elements in the world came from, because starting with hydrogen the cooking processes inside the stars would not make much more than helium and less than half a dozen other elements. Faced with this problem, British astronomer Professor Fred Hoyle, and American physicist Edwin Salpeter, said that there is one way out, If 3 helium atoms could come together to form carbon, we can easily calculate how often that should happen in a star, and it turns out that it should never happen much except for one possible accident. If there happened to be an energy level at 7.82 million volts in carbon, then the 3 helium atoms would come together, and before they came apart, would stay together a little longer on the average than they would do if there were no level at 7.82. And staying there a little longer, there's enough time for something else to happen, to make other elements. If there was a level at 7.82 million volts in carbon, then we could understand where all the other elements, in the periodic table, came from. And so, by a backhanded, upside-down argument, it was predicted that there is in carbon a level at 7.82 million volts. And experiments in the laboratory with carbon showed that indeed there is. Therefore, the existence in the world of all these other elements is very closely related to the fact that there is this particular level in carbon. But the position of this particular level in carbon seems to us, after knowing the physical laws, to be a very complicated accident of 12 complicated particles interacting. So, this illustrates that an understanding of the physical laws does not necessarily give you an understanding of things of significance in the world in any direct way. The details of real experience are often very far from the fundamental laws. We have a way of discussing the world, when we talk of it at various hierarchies, or levels. Now, I do not mean to be very precise, dividing the world into definite levels, but I will indicate, by describing a set of ideas, what I mean by hierarchies of ideas. For example, at one end we have the fundamental laws of physics. Then we invent other terms for concepts which are approximate, which have, we believe, their ultimate explanation in terms of the fundamental laws. For instance, heat. Heat is supposed to be jiggling, and the word for a hot thing is just the word for a mass of atoms which are jiggling. For that fundamentally we should think of the atoms jiggling. But for a while, if we are talking about heat, we sometimes forget about the atoms jiggling, just as when we talk about the glacier we do not always think of the hexagonal ice and the snowflakes which originally fell. Another example of the same thing is a salt crystal. Looked at fundamentally it is a lot of protons, neutrons, and electrons, but we have this concept salt crystal, which carries a whole pattern already of fundamental interactions. And so it is with the word pressure. Now, if we go higher up from this, in another level we have properties of substances, like refractive index, how light is bent when it goes through something, or surface tension, the fact that water tends to pull itself together, is described by a number. I remind you that we have to go through several laws down to find out that it is the pull of the atoms, and so on, but we still say surface tension, and do not always worry, when discussing surface tension, about the inner workings. Sometimes we do, sometimes we don't. Going on up in the hierarchy, with the water we have waves, and we have a thing like a storm, and the word storm, which represents an enormous mass of phenomena, or sunspot, or star, which is an accumulation of things. And it is not worthwhile always to think of it way back. In fact, we can't, because the higher up we go, the more steps we have in between, each one of which is a little weak, and we haven't thought them all through yet. As we go up in this hierarchy of complexity, we get to things like frog, or nerve impulse, which is an enormously complicated thing in the physical world, involving an organization of matter in a very elaborate complexity. And then we go on, and we come to words and concepts like man, and history, or political expediency, and so forth, which is a series of concepts that we use to understand things at an ever higher level. And going on, we come to things like evil, and beauty, and hope. Now, which end is nearer to the ultimate creator, or, if I make a religious metaphor, which end is nearer to God? Beauty and hope, or the fundamental laws? I think that the right way, of course, is to say that what we have to look at is the whole structural interconnection of the thing is the thing we have to look at. And the sequence of hierarchies, and that all the sciences, not just the sciences but all the efforts of intellectual kinds, are to see the connections of the hierarchies, is to connect beauty to history, is to connect history to man's psychology to the working of the brain to the neural impulse to the chemistry, and so forth, up and down both ways. And today we cannot, and it is no use making believe that we can, draw carefully a line all the way from one end of this thing to the other. In fact, we've just begun to see that there is this relative hierarchy. And so I don't think either end is nearer to God. And as to stand at either end, and to walk out, off the end of the pier, only, hoping that out in that direction is the complete understanding, is a mistake. And to stand with evil and beauty and hope, or to stand with the fundamental laws, hoping that way, to get to deep understanding of the whole world, with that aspect alone, is a mistake. And it is not sensible either, for the ones who specialize at one end, and the ones who specialize at the other end, to have such disregard for each other. They don't actually, but the people say they do, but that actually the great mass of workers in between, connecting one step to another, are improving all the time our understanding of the world, both from working at the ends and working in the middle, and, in that way, we are gradually understanding this this tremendous world of interconnecting hierarchies. Modern science arose despite the prevalence of superstition, such as those wrong ideas by the ancient Greeks, and it largely arose because of the Judeo-Christian worldview. For instance, Aristotle, of the 4th century BCE, taught that the processes of decay only happen on the earth, and believed that the heavens above and the things in it were eternal and unchanging, without decay. This dogma prevailed for many centuries, until the 18th century, when scientists formulated the concept of entropy, which suggests that all matter, whether on Earth or in the heavens, has a tendency to decay. Lord Kelvin was one of those early scientists who helped to advance this concept. He noted what the Bible says about heaven and earth: just like a garment they will all wear out. Psalm 102, verse 25 and 26. However, Kelvin also took note that the Bible also taught that God's will was for the earth to remain forever, Ecclesiastes 1:4, that God has decided to prevent such deterioration from destroying his creations. Psalm 102, verse 26 says, "They will perish, but you will remain, just like a garment they will all wear out, just like clothing God will replace them, and they will pass away." But some materialist atheists were still holding to a past eternal steady-state universe, until it was debunked by other further scientific discoveries, when Einstein's theory of relativity and astronomical observations suggested that the universe was expanding, thus implying a beginning point of time and space, and this was further confirmed by the discovery of the cosmic microwave background radiation. Thus, to the chagrin of materialist atheists, the universe requires an explanation for its existence. And, for materialists, the problems only kept getting worse from there. Regarding Richard Feynman's 1964 lecture on the distinction of past and future, it's interesting how Feynman refutes this sometimes mythical conflict between science and religion. Even when using God as a religious metaphor, studying one aspect of the universe alone is not going to get you necessarily nearer to God than what another aspect might be able to do. not without taking the big, complex picture into account, that is, with many aspects of the world altogether, many interconnected hierarchies of complexity. In a similar way, neither observing only two molecules colliding will ever distinguish the direction of time's arrow. Not with that aspect alone, you need to zoom out and look at the total effect, the bigger picture of what is going on, with billions and billions of atoms jiggling and bouncing, and it is only then, at least at the level of immediate human perception, closer to the macroscopic level, is when you begin to get a clear distinction of time's arrow. It is only from distinguishing the direction in physical change, which is always from order to disorder, but only at a larger part of the whole system is when you begin to get at least a partial understanding of it, that the particular fundamental basis of it is the laws of probability and statistical mechanics. The entropy phenomenon gives us an empirical handle on the remote past in the same way the apparent expansion of our universe is claimed to do. In more recent times we know that if we backward extrapolate in time and infer that the universe of the past was more densely compacted, inferred from the redshifts of galaxies, the apparent brightness of standard candles, such as Cepheid variables, and how their pulsation period is directly related to their intrinsic luminosity, the redshifts of 1A-type supernovae and their apparent brightness, and so on. This not only infers their distance but is believed to indicate how far back into the past we are observing them, and we can also independently observe and measure from the entropy principle. Everything we know of is increasingly becoming more disorganized, and we might therefore logically infer, from these separate lines of investigation, that in the past such things had a beginning. And they began in a state of maximum order, the inference of which is due to the observed direction and rate of decay, just as we observed the way things happen right now, and will continue to happen, for as long as the universe exists in an out-of-equilibrium state. Scientists tried to determine the age of many other things by their rate of decay, and this same type of reasoning can be applied to the entire universe as well. The scientific question can rightfully be asked, what, or who, in the beginning, created a more ordered universe? A question that naturalistic science possibly cannot answer, and where science might stop, and where philosophy and theology might continue on. Paradoxically, this natural law, the second law of thermodynamics, is emergent from the other laws built into the universe, and also nonetheless fundamental but in a different way to other natural laws. It seems to be statistical, and purely informational, and asymmetrical, irreversible. There is a one-way characteristic to it. So at the macroscopic level, much of which we experience in our everyday life, entropy is described as the second law of thermodynamics in terms of differences in pressure, temperature, density, color, height or levels, and so forth, on average trying to mix and equalize and become more uniformly distributed, and the rate at which this decay, or loss of potential flow, or loss of usable energy, is happening. At the fundamental level, the submicroscopic level, the cause of such phenomena is described in terms of the random perpetual motion of particles jiggling and bouncing and statistically tending toward randomness and disorganization, becoming evenly mixed. The overall result is that a closed isolated system runs out of potential energy. From a materialist perspective, one that is absent of any affirmative theology, in physics the universe is considered to be a closed system. Feynman's thought experiment involving the ratchet and vane cannot happen in real life because it would take vastly more than just 2 or 3 molecules to move the pole a distance of one tooth, and even if in a scenario where turbulent wind currents occasionally move the wheel in either direction, the probability of the pole coming back down on a tooth as an inclined plane is very low. But most prominently is the fact that such a pole would not jiggle at the macroscopic level as described when heated, but if anything at all might melt if hot enough. The jiggling of the atoms would be the heat of the object itself, and, above a certain temperature threshold, the atoms jiggling is also the observed macroscopic phenomenon of melting. So obviously his thought experiment should not be taken too literally. It is oversimplistically analogizing the irreversible phenomena of nature to highlight a principle. Similar too, is for his wet towels analogy, because evaporation was not factored in. It is analogy that excludes extra variables for reductionist simplicity, in order to easily understand the more fundamental concept, that an out-of-equilibrium condition is needed, for energy to be available, for it to do something useful. Feynman acknowledged the very mysterious level in the entropy phenomenon, even when studying and calculating the trajectory of the individual particles in a reduced theoretical system. In reverse time their trajectories still compute, and yet this outcome does not happen on the larger scale, the big picture of things. Things in reality do not become less random and separated in this way, and yet each individual molecular collision, when the movie of it is reversed, is still okay. This is one of those conundrums that almost seems to defy human reasoning ability. The fundamental solution to partially understanding this is to consider possibility spaces, the laws of probability, within systems of organization, and calculate how many possible states there are of disorganization as compared to possible organized states of being, within the same possibility space, and thus try to calculate the ridiculously low probability of the organized arrangement therein never happening. In this case the organized state is very simple compared to some other known systems, it is just a lopsided separated mass of two different liquids, and yet despite this, the chances of them separating by themselves are indistinguishable from zero. This provides a partial understanding of why things will go one way overwhelmingly most of the time bar one highly improbable organized condition, which, due to chance, in most cases is practically impossible given the limited age of the universe, and that is even in a relatively simple system of molecules bouncing around, without any mechanistic integrated complexities like what are found in biological systems, which under those circumstances of irreducible complex functionality, seem not only improbable, but impossible. Feynman used a form of hyperbole by deliberately understating it, by saying that it would never happen in a million years, because, in theory, incomprehensibly more time would be needed. This is also a critical issue with biology and Darwinian evolution, since genetic science has uncovered the copying mistakes that happen within DNA code, and not all those errors are corrected but instead passed on to the next generation and so forth. So it's no real logical leap to assume that entropy will be increasing over time and over successive generations in the biological phenomena of the world as well. And if that is all what exists, for nature to select, then, without miraculous intervention, it appears most certainly doomed. Non-reductive physicalism is the view that all entities and properties in the world are fundamentally physical, yet higher-level properties, especially mental states like consciousness, cannot be reduced to, or identified with, basic physical laws or particles. While Feynman was a physicist and not a theologian or a philosopher of mind, his argument provides the scientific scaffolding that non-reductive physicalists use to explain how complex phenomena, like consciousness or divine action, can exist in a world governed by simple physics. Some might imagine that this might lend weight to the compatibilist view, the view that free will and determinism are compatible, arguing that individuals can be free and morally responsible even if their actions are determined by prior causes. So, remorse, regret, and hope, and so forth, are words that very obviously distinguish past and future. Others, who reject compatibilism, still argue that it's all fully deterministic, and that there are still serious consequences for criminal behavior due to cause and effect, therefore responsibility is not diminished more than in the compatibilist worldview. So, it appears that if some people make the argument that determinism might be used as an excuse for evading legal responsibility, they would be wrong, because within either worldview there are always physical consequences for whatever actions have been initiated. Feynman did not support the steady-state theory. By the time he delivered the Messenger Lectures at Cornell in 1964, which became the book The Character of Physical Law, the scientific tide had turned decisively toward the Big Bang, evolutionary, model. When Feynman was speaking in 1964, the steady-state model, championed by Fred Hoyle, was in its death throes. That very same year, Penzias and Wilson discovered the cosmic microwave background radiation, which was said to be the smoking gun for the Big Bang. Feynman's entire argument regarding the arrow of time relies on the universe having an ordered beginning, a boundary condition. In physics, a boundary condition, or initial condition, is a set of information that is not contained within the laws of nature themselves, but is necessary to get a specific result from those laws. If you look at the equations for two atoms colliding, the equations work perfectly fine forward and backward. There is no direction in the law. Therefore, the reason our world has a direction, going from order to disorder, must be a boundary condition. You might think of it this way: the laws tell you how things change. The boundary conditions tell you where things started, but they don't tell you why. The Big Bang requirement, for the second law of thermodynamics, entropy increasing, to work as we see it, the universe must have started in a state of extremely low entropy. Physics cannot account for this ordered start, so this is the boundary where a physical explanation is not possible, where science can go no further, where materialists can engage in only metaphysical speculation, if they can be bothered. So the steady-state idea has a problem. If the universe were eternal and unchanging, steady-state, it would be difficult to explain why we haven't reached a state of heat death or total equilibrium already. The only reason we can distinguish the difference between the past and the future is that we exist in the aftermath of a vast, organized event. Feynman leaned toward the Big Bang because the physics of entropy demanded a starting point of order, yet he was characteristically cautious. He didn't like dogma. But, he viewed the steady-state model as increasingly inconsistent with the asymmetry he was observing in the laws of thermodynamics. This is where the scope of naturalistic science reaches its limitations. How can there be such order? The boundary condition. So, Feynman, as flawed as he was, like all humans are, nonetheless made a great contribution to science in helping us understand the character of physical law. He acknowledged, it is necessary to add to the physical laws the hypothesis that in the past the universe was more ordered than it is today. And that statement has profound implications. Theologians argue that while science explains the laws of physics, it cannot explain why the universe was set up in such a highly improbable, ordered way to begin with. The universe needed a very specific kind of Big Bang. Secular cosmologists also understand the problem. Roger Penrose, who is not a theologian, building on the logic Feynman discusses, famously estimated that the aim of the Creator, or the precision of the initial conditions, to produce our low-entropy universe would need to be accurate to 1 part in 10 to the power 10 to the power 123. This degree of order is so vastly precise, it is unfathomable. So you can see why it is called a boundary condition. It is hard to imagine how science can go any further beyond this point, without engaging in metaphysical speculation, as some are doing. To a theologian, this looks like divine providence encoded into the very first nanosecond of the universe, theoretically somewhere from t equals 0 to before 10 to the power minus 43 seconds of physical existence. When you connect fine-tuning to boundary conditions, you are essentially asking if the universe started with a massive injection of specified information. The initial boundary conditions of the Big Bang weren't just low entropy, ordered, they were specifically ordered to allow for stars, chemistry, and eventually, observers. If the expansion rate or the jiggle, as Feynman calls it, were off by a tiniest fraction, the universe would be dead. Either a black hole or a thin gas at most, or, if protons can decay, perhaps just leftover radiation. Theologians argue, as do physicists, that laws are mindless descriptions of what happens next, but it seems that information is a product of mind. Increasing entropy is the natural undoing of what a mind has organized, and the second law of thermodynamics seems like an emergent consequence. of what was originally organized. We are thus led to a more profound question: can the code of DNA emerge purely from the laws of physics, or does it require a new boundary condition or input of information? When we scientifically talk about evolution, what we are really talking about is the naturally progressive undoing of the initial conditions, whatever they might have been. Atoms jiggling according to laws, like gravity or electromagnetism, don't naturally form sequences that represent something else. The laws, physics and chemistry, these explain how a carbon atom bonds to a nitrogen atom and so on. They are law-like and repetitive, like crystals. The seemingly insurmountable difficulty for the materialist is the code in DNA. This is a specified sequence, like the letters in a book. The meaning, the protein it builds, and other sophisticated runtime code sequences, isn't determined by the attractive or repulsive forces on the base pairs within the DNA, like the chemistry of the ink of a book, but by the order of the letters, the order of the base pairs, that speak. So, is life a new boundary condition? Some theologians, and information theory proponents, argue that the origin of life represents a second Big Bang of information. Is it the spoken word of God perhaps? Is this question only a religious metaphor? It looks highly unlikely. If any sequence is chemically possible, then the specific sequence that creates a functional cell is statistically miraculous, and that scarcely begins to explain the scope of the entire problem. It's vastly even more difficult than that. So, the entropy law is a law of irreversible phenomena. It goes one way through time, and many believe it even defines the one-way direction of time itself, and gives the concept of time meaning to the operation of the human brain. Some go even further and say that time is just an illusion, an abstract notion born of the human mind from the one-way direction of change in the relative movements of many particles interacting, the physical principles which the workings of the human brain and the human senses also seem to operate within, and rely on, for their motion and ongoing functional dynamic, but, because of being embedded in this space-time framework, it is then difficult for the human intellect to think up concepts outside of it. Physics urges us to face the cold hard reality of things. Everything in the universe decays over time. Even functional information becomes more degraded over time and more scrambled. Everything, every hierarchy of complexity, eventually becomes more disorganized, more random, more mixed up, completely scrambled, and more uniformly distributed over time, because of the laws of probability that determine the outcome of all particles in motion jiggling and bouncing. And there is no escaping it, not for any of us, for we are all subject to it. In human terms, there is no way of defeating entropy. Sooner or later, without a divine miracle, without a savior, whether you believe it possible or not, no matter what we try and do to delay it, entropy always wins, in the end. Degradation and disorder of one kind or another affect us all over time, and it seems that it would be miraculous if we never died at all. We are at present doomed, due to the chaos of irregular perpetual motions, of the particles, of which we are made. It is very humbling to contemplate. Increasing entropy, until a maximum amount is reached, within the system, at every level of reality, so far observed, has always proven to be inevitable. This is the uniform and repeated experience in all of physics in the laboratory, and everywhere else observed in nature. And most significantly, from a scientific perspective, it has been tested many times, and never falsified. Even though the argument has always been open to attempted falsification and rigorous testing, it remains unfalsified, both at the experimental and theoretical level. Entropy has been categorized by various people into different types, for example, Boltzmann entropy, information theoretical, Shannon entropy, quantum entropy, and entanglement entropy, decoherence, thermodynamic entropy, macro entropy, organizational entropy, genetic entropy, and so on, maybe all the different hierarchies of complexity that you can possibly imagine. All types of entropy without exception are subject to both physical laws and statistical probabilities. All things known to physics and information theory, everything involving matter and motion, and information. It is open to both empirical testing and theoretical investigation, and therefore, the statistical mechanics of it all is one of the most scientifically and mathematically established arguments of all time. There are, from this inconvenient truth, dire implications for the type of Darwinian philosophy that appeals to materialist evolutionism, because if the genetic code is a very specified language, as science is surely beginning to reveal, then it would seem that the materialist evolutionist emotionally clings to a hopeless idea that some unknown natural mechanism, perhaps using natural selection, might overcome entropy locally, and permit an imagined localized upward Darwinian evolution to be possible. Whereas it seems the creationist has accepted the cold hard scientific facts of thermodynamics and its statistical improbabilities, and is therefore convinced that upward Darwinian evolution, macroevolution, is just a myth, and nothing more. And so, whether there is confirmation bias or not in all of this, such as with interpretations of fossils and so forth, just because a person, whether evolutionist or creationist, might wish something to be true, or false, it doesn't make it so, no matter what convoluted fanciful ideas a person thinks up. Even if both opposing beliefs might be somewhat emotional to start with, that is, one born out of a so-called anti-religious predisposition and the other a more traditionally religious proclivity, on the face of it, it seems obvious which belief objectively agrees more with the empirical science, and which ideology subjectively disagrees with empirical observation of physical processes. For the origin of life, the implications of the evidence regarding the entropy principle look even more dire, for the notion of a naturalistic abiogenesis that might be assumed from materialist atheism. Theoretically, any single protein molecule, whether functional or non-functional, forming by chance in a hypothetical soup of amino acids is 1 in 10 to the power 65, theoretically the total number of all possible proteins being 10 to the power 65. It's like searching for one specific atom in our entire galaxy, the estimated total number of atoms in the galaxy roughly being anywhere from maybe 10 to the power 65 up to 10 to the power 68. More recently, some estimates for forming a single functional protein, approximately 150 amino acids long, by random chance is as low as 1 in 10 to the power 164. And yet another estimate from rigorous scientific research is, for every functional protein, there are 10 to the power 77 non-functional possibilities. That would be conservatively 1 billion Milky Way galaxies worth of atoms to try and describe that number, according to the current scientific theories. Over the entire 3.5 billion year history of life on Earth, only an estimated 10 to the power 40 individual organisms have ever lived. That's not enough time to make likely even one functional or non-functional protein spontaneously form, let alone a so-called simple life form. And of course it is now well known that even those forms of life are not simple at all, but vastly far from simple. Be it a cell or a virus, both of which are made out of multitudes of many, many different types of functional protein molecules, and also DNA, RNA, etc. Theistic evolution, a scientific, philosophical, and theological critique. J.P. Morland, Stephen C. Meyer, Christopher Shaw, and K. Geiger, Wayne Grudem. We must therefore dispense with irrationality, and the incredulity of abiogenesis or macroevolution, and indeed we must accept what proper empirical science has given us instead, especially when we view DNA and its symbolic code with some similarity of functionality to the words and letters in a book. To quote Sir Arthur Eddington, the practical measure of the random element which can increase in the universe but can never decrease is called entropy. Measuring by entropy is the same as measuring by the chance explained in the last paragraph, only the unimaginably large numbers are transformed, by a simple formula, into a more convenient scale of reckoning. Entropy continually increases. We can, by isolating parts of the world and postulating rather idealized conditions in our problems, arrest the increase, but we cannot turn it into a decrease. That would involve something much worse than a violation of an ordinary law of nature, namely, an improbable coincidence. The law that entropy always increases, the second law of thermodynamics, holds, I think, the supreme position among the laws of nature. If someone points out to you that your pet theory of the universe is in disagreement with Maxwell's equations, then so much the worse for Maxwell's equations. If it is found to be contradicted by observation, well, these experimentalists do bungle things sometimes. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation. Eddington, A.S., The Nature of the Physical World, 1928, The Gifford Lectures 1927, Cambridge University Press, Cambridge UK, 1933, reprint. Pages 74-75. Emphasis original. Since that statement was written, our knowledge of biology and genetics has increased to the point where by extension we can legitimately say that there is nothing left for the pet theories of abiogenesis and macroevolution, but to collapse in deepest humiliation. If genetic code had not turned out to be a specified code at all, but all just random nonsense instead, then all the theological arguments might have collapsed, and the nihilist view of some existentialists would have become the dominant view, perhaps the only view, in today's world, and the ultimate human outlook would have been that of only futility, and no amount of light that we had shone in the darkest places of physical reality would have given us any lasting meaning or purpose. But as it turns out, the deeper science digs, the more it discovers about the remarkable sophistication of the world that we are all a part of. The biblical-based religious worldviews, whether you believe them to be true or false, are in agreement with these empirical arguments, but such a bleak outlook, the theoretical heat death of the universe or the gene death of all species, is not without hope. Even the famous Richard Feynman was compelled to ask, how did the thing get ordered in the first place? It's a good scientific question. And science alone might never be able to answer it. What makes this even more remarkable is that the question was asked at a time where the Big Bang theory had just begun to be more established in the scientific community and the steady-state theory was in its death throes, advocated by people like Fred Hoyle, who postulated that the universe had no beginning but had always been there from eternity past. But even without the idea of the universe having this kind of beginning that the Big Bang ascribes, the entropy law itself independently was pointing to the universe having a beginning of maximum order, maximum organization. One can logically see that if the universe were past eternal, it would have run out of energy and organization by now, actually an eternity ago, but we all can clearly see from our own personal experience that this has not happened. Even now, for those who find the concept of the Big Bang theory plausible, it looks highly obvious that the universe had to begin more ordered, which means that the existence of an intelligent creator seems to be far more probable than not, even if it makes no sense to us how this original organizer came to be. It's like in the well-known Sherlock Holmes stories. When you have eliminated all the impossibilities, then what remains, no matter how seemingly unlikely, must be the truth. Reasoning up from the most fundamental axioms that we are sure of, so far we might only conclude that the ultimate primary cause of everything is not subject to the laws of nature. This is the boundary condition that some people will not accept as reality because there can be no scientific explanation for it. So, although there is this so-called divine hiddenness, where we find ourselves living in this vast sea of demon-haunted darkness, we are able to shine our little science candle on at least some aspects of it and reveal certain truths. For those people who choose to take biblical doctrine as their axiom and put it to the test, we have an account where the Son of God said, "Heaven and earth will pass away, but my words will by no means pass away." Matthew 24:35, Luke 21:33, Mark 13:31. This statement seems to be a hyperbole because other scriptures show that heaven and earth will endure forever. So what was his point? Genesis 9:16, Psalms 104:5, Ecclesiastes 1:4. It might mean, at least in part, that whether the universe were in existence or not, God's laws or words remain forever, perhaps including the laws written into the universe. Even if the universe were to decay away to nothing, the laws themselves would still hold, as more fundamental. Ludwig Boltzmann, who lived from 1844 to 1906, is widely considered to have been an atheist or at least a non-religious, materialist thinker. However, he did not heavily publicize his private religious views, but he was able to statistically model the behavior of gas molecules and arrived at a mathematically undeniable conclusion. He discovered in his equations that dynamically ordered states are, as he put it, infinitely improbable. There are overwhelmingly many more possible disordered states in a system than possible orderly ones, and therefore a system will virtually always be found either moving towards disorder or in the state of maximum disorder. Why? Because it is statistically inevitable. Simply put, it is more than likely to happen. Depending on which system you are describing, another way of looking at it is, there are vastly more ways of something going wrong than there are of something going right. Therefore, if the system is left to itself, it will always go wrong over time. There are vastly more ways of something being disorganized than there are of something being organized. Therefore, if the system is left to nature, it will always become disorganized over time. There are vastly more ways of something being evenly mixed and spread out than there are of something being separated and lopsided. Therefore, if the system is left to itself, it will always go toward a maximum state of being completely mixed or spread out over time. But the fundamental idea of increasing randomness or a reductionist idealized potential maximum state of disorganization and randomness remains, because it is a condition of highest probability. Some people argue over the word disorder. Disorder, to describe entropy, is a subjective term, but in the context of physics it is referring to the state that the decay of a system will result in. The state of highest probability. For example, randomness, homogeneity, equilibrium, the lowest state of potential energy, or being spread out, dissipated or uniformly distributed, depending on the system being described. A.B. Pippard said, "There is thus no justification for the view, often glibly repeated, that the second law of thermodynamics is only statistically true, in the sense that microscopic violations repeatedly occur, but never violations of any serious magnitude. On the contrary, no evidence has ever been presented that the second law breaks down under any circumstances." A.B. Pippard. Elements of Chemical Thermodynamics for Advanced Students of Physics, 1986. Heat flows from hot to cold regions because the laws of probability favor a more uniform distribution of heat energy. Physicists sometimes postulate the unlikelihood of all the air molecules in a room all by accident coinciding in one side of the room where the other side is left with an empty vacuum. But this would be tantamount to a miracle, and naturalistic science cannot tolerate such a notion. You would have to wait for vastly longer than the age of the universe for this to happen by chance occurrences, which is a gross understatement beyond human comprehension. There is no 10 to the power of any negative number small enough that can be envisaged to describe such a ludicrously tiny probability. The thought experiment itself is not accurately representative of reality because atoms electromagnetically repel each other, and so the repulsive forces between the molecules would never allow such a thing to happen like that anyway. The situation is far more dynamic than described. Some physicists think that this indicates an even more fundamental level of reality. But for reductionism, repulsive forces are not included in the thought experiment to gain a more fundamental understanding of the basic underlying statistical principles involved. Some people imagine that with infinite time, and where the particles of the universe are limited or even unlimited in number, that this will allow at least a low probability where they are still bound to repeat their same arrangements an infinite amount of times, thus orders sometimes accidentally arising, and history will repeat itself forever. But nobody knows whether the universe is just made of only finite particles or not. Why does relativity theory not cooperate with quantum mechanics? There could be many aspects of the universe that are not only discrete but analog as well, in which case there might never be repetition. So there is more than one way to think about infinity, not just the amount of time or numbers of particles but also possible non-discrete aspects within the universe as well. But, for now, although it's fun to think about, such metaphysical speculation is for the philosophers. But do the mathematical principles of this second law only apply to atoms and molecules? No. E.S. Greens said, "It is a very broad and general law, and because its applications are so varied it may be stated in a great variety of ways." E.S. Greens. Principles of Physics 1982. Isaac Asimov said, "All of them are equivalent, although some very sophisticated mathematics and physics is involved in the showing the equivalence." Isaac Asimov, In the Game of Energy and Thermodynamics, You Can't Even Break Even, Journal of the Smithsonian Institute, June 1970. Entropy is a description of many parts interacting according to probability. It is by definition insufficient to describe it in terms of only one or two individual parts interacting, but instead, it is a description of an enormously complex outcome of probabilities that can usually only be rounded out into a convenient scale of reckoning. Fluctuation is a reversal but is not entropy reversal within any system but just part of the overall entropy principle of increasing randomness. Fluctuation and randomness in this way are usually the same. Do atheists and evolutionists ever ask, is it possible that everything we know of started out more organized? So far, the observable evidence agrees with this notion. Any possible theorized localized micro-reversals have never been observed to stop this from happening. Not even in biological systems. Surely if it were true, it seems likely that scientists would have seen it by now, but, despite some dubious claims, they have not. By this we are led to the logical conclusion that whatever the first cause of everything was, it must be a primary causation without a beginning. Whether it be a natural past eternal process, or an infinite, past eternal, intelligent creator. This first cause argument would still hold even if you postulate that our experience of time is not real but only emergent. Nevertheless, in light of the entropy principle pointing to an organized beginning, the intelligent cause seems more plausible. In materialist terms, have we missed something? Because this then brings forth a logical paradox that the order had to suddenly appear at the start of everything. This is not what we understand to be natural. Scientifically we never observe complex things like biology beginning more ordered only due to less complex natural processes. It is logical to suggest therefore that whatever put this kind of order there, had to be something else even more ordered, beyond only unplanned undirected natural processes. Perhaps some kind of organizing intelligence. By extension, there must be a past eternal or self-existent entity, perhaps that same entity intelligent, without a beginning, not subject to the entropy law, even if we can never understand how it might be possible. Is this where we reach the limits of science and human understanding? As uncomfortable as it might be from a materialist perspective, the scientific evidence points us in that paradoxical direction. Logic leads us to a seemingly illogical conclusion, but rationality demands that it be faced, and the only option left from here is an extrapolated leap of faith based on repeatable observations. And many scientists have begun to realize this, and for them, God is not just a religious metaphor anymore. Zoologist Edward Luther Kessel was an American biologist who was known for his work as an entomologist and his writings to reconcile science and religion. He reveals some interesting facts about a law of thermodynamics, the law of entropy as it is often called. In an article entitled, "Born to Believe in God," Although it is difficult to find the original source, he is quoted by different people as saying, "The law of entropy states that there is a continuous flow of heat from warmer to colder bodies, and that this flow cannot be reversed to pass spontaneously in the opposite direction. Entropy is the ratio of unavailable to available energy, so that it may be said that the entropy of the universe is always increasing. Therefore the universe is headed for a time when the temperature will be universally uniform and there will be no more useful energy. Consequently there will be no more chemical and physical processes, and life itself will cease to exist. But because life is still going on, and chemical and physical processes are still in progress, it is evident that our universe could not have existed from eternity, else it would have long since run out of useful energy and ground to a halt. Therefore, quite unintentionally, science proves that our universe had a beginning. And in so doing it proves the reality of God, for whatever had a beginning did not begin of itself but demands a prime mover, a creator, a God. Even if this were a spurious quote, the statements therein are technically correct, and well argued. If you are familiar with the second law of thermodynamics, then you will understand the following logic. Even though someone of the atheistic persuasion might say that God demands a scientific explanation in his own right, from a scientific physics perspective we nonetheless all realize that there had to be a self-existent primed mover of some kind as the cause of everything, and it had to have been of a more organized existence. And materialists might imagine an organized physical existence, to start it all with. However, because the scientific evidence suggests that the primed mover had to be, not only self-existent but also, more ordered, and the most organized of all, more specified than anything that came after it, such self-existence cannot be physical. So saith the entropy law. The mistake that materialists make, is, demanding a physical explanation for a God who created the physical laws, for which there cannot, and never, be. For there is the origin of time, space, matter, and energy to consider. So, the physical evidence demonstrates the existence of something not seen, and not necessarily within the physical universe, and something that can only be non-physical, supernatural, powerful beyond measure, eternal or timeless, and incorruptible. You may as well call it God. So science points in that direction, but won't ever be able to fully explain it, and it is more than just a metaphor, something else is required. So faith is not from personal incredulity, but it is based on irrefutable observable evidence. This very biblical argument at Hebrews chapter 11 verse 3 states, "By faith we perceived that the systems of things were put in order by God's word, so that what is seen has come into existence from things that are not visible." The universe seems to point to something beyond itself. So, despite the limited scope of materialism, one might conclude, organized systems require an organizer, a mind, and, ultimately, a God.